Hello students, welcome to the series of lectures of basic electrical engineering. Next class, as I told, I will start the previous papers. So this is of previous papers exams, question papers, questions we have taken. So let us solve the previous papers questions here. So this is one of the question, it is given in the previous paper, given for 6 marks. Let us see the solution. So here a circuit consisting of two parallel resistors having resistances of 20 ohms and 30 ohms respectively. So it is given in the statement form. You have to convert into the circuit form by using these statements. So a circuit consisting of two parallel resistors. So first I am drawing the two parallel resistors here. So like this. So having a two parallel resistors. So parallel means we will draw like this, right? So what is the values we will write later, respectively connected in series with 15 ohms. So this while I explaining the theory only, this model I told in a series parallel combination, it might be in a third class, you go and check it. This model is very important. So this is the circuit is given. If current flowing through 15 ohms resistor is 3 amperes. Now write the values for this. So let us write the values. So here 20 ohms and 30 ohms, they both are in parallel, they told. Next it is in series with 15 ohms and current flowing through this 15 ohms, it is given as 3 amperes. Just I have written given data. So what is the question he is asking? First question, find the current through the branches. So each branch, what is the current flowing through the each branch he is asking. So voltage across whole circuit. So what is the voltage across this entire, that means let us draw the voltage across this entire circuit. So let us take the voltage across this entire circuit. I am taking it as that is some V across this entire voltage circuit like this. Okay, right. So power consumed by 20 ohms and 15 ohms resistor. So for this, first you see, first question I am solving here. Let us take the first question. Current flowing through branches. So here it is given. So if you see here that 3 amperes, after coming to that point, it is dividing as some different currents. Let us consider that currents as I1 and I2, and here the 3 amperes, that current I am considering it as I. So whenever you see this, you have to get the idea that you have to apply the current division rule, because you know the current, total current here, you have to find what is I1 and I2. So you have to apply the current division rule. So let us take the, what is I1 is equals to I into, you have to multiply with the opposite resistance. For I1, what is the opposite resistance? That is 30. So 30 divided by 30 plus 20, that is I1. Next you see I2, I into, what is opposite resistance for 30, that is 20, that is 30 plus 20. So you know the total current here, that is 3 amperes, 30 divided by 50. So here also you know the total current, 3 into 20 divided by 50. So it will get cancelled. So it is also gets cancelled. I think so. This is 1.8 amperes. This is 1.2 amperes. Totally must be 3 amperes. This is the current flowing through individual branches. That is the first question. Next, voltage across whole circuit. For finding the voltage across whole circuit, first I am converting this parallel resistance into one equivalent resistance. Just I am converting, giving the name it as RP. So just I will find first RP. What is RP here? RP is equals to, that is 20 in parallel with 30 means 20 into 30 divided by 20 plus 30. So I think so it is 600 divided by 50. So it is of 12 ohms. It is of 12 ohms. So 15 ohms, this 15 ohms and this 12 ohms, they both are in series, and total current flowing is, it is given it as 3 amperes. Now you can apply the voltage. So just I am solving the second problem here. What is the total voltage means? Total current into total R equivalent resistance. So what is the total R equivalent resistance here? That is 15 ohms in series with 12 ohms, that is 27. So that is total current is 3, that is 27. So I think so it is 91. It is 91 volts. Is it right? So 27 into 3, 60. I think, sorry, it is 81. Is it right? So it is 81 volts. Sorry, it is 81 volts. That is the total voltage across the circuit. And third question, let us see third question. Power consumed by 20 ohms and 15 ohms. So you are calculated what is the current flowing through here and what is the current flowing through this resistor and this resistor. Now you have to, what is the question is asking, what is the power consumed by 20 ohms. So power consumed by 20 ohms, just I am writing it as P20, that is I20 current flowing through 20 whole square into R, that is current flowing through, that is I20, you got it as, that is 1.8 whole square into current, sorry, resistance is, that is 20. So what is the power absorbed by 30 ohms, you can take it as, that is I 30 ohms whole square into R, that is 1.2 whole square into 30. So this answers I am leaving for you. So units will be watts for this power. So this is the one of the very simple question is asked. I think so you understood what is the importance of this current division rule. So this is of very important, current division rule is very important, you have to understand. So this is one of the question it is given in the previous question papers. Next question, see the next question. See here, it is given the once again the next question it is given in the another question paper. So this is also given for 6 marks. Let us see this question also. This is also one of the application of the current division rule. Here the total current, just I am writing, the total current is given as 9 amperes. The total current is given as 9 amperes. And you have to calculate what is I1 and what is I2, because the opposite resistance are given, and calculate the power consumed by each resistor. That is the question he is asking. What is the power consumed by each resistor he is asking. That is the question it is asking here. So that you have to understand. So let us calculate what is I1. So first I1 is I into, what is the opposite resistance for I1? That is 4 divided by 4 plus 8. Next I into, that is what is the opposite resistance for 4? That is 8 divided by 4 plus 8. So here the total current is 9 into 4 divided by 12. Here also total current is 9, 8 divided by 12. So 4 ones are 4 threes, 3 threes, that is here it is 3 amperes, means definitely you will get 6 amperes here. 4 twos are 4 threes are 3 threes are. So here you will get the 6 amperes. Totally you have to get the 9 amperes. Then only your answer is correct. Now you got the individual current. Next, power consumed by each resistor. So power consumed by 8 ohms resistor, just I am writing, that is current flowing through 8 ohms whole square, that is given as I1 square into 8. That is in the problem it is given. So I1 you got it as 3 whole square into 8, that is 9 into 8, that is 72 watts. That is the 72 watts. Next, power consumed by 4 ohms resistor, that is I2 square into 4, that is I2 value got it as 6 whole square into 4, that is 36 into 4, 120. It is 144 watts. That is the total power consumed by each resistor. Power consumed by each resistor. That is the question it is asked in the previous papers. This is given for 6 marks. So I think so you understanding that how much of importance is given for current division rule. Current division rule you have to understand, very important. So this is all previous latest question paper, just I have collected and I am solving here. Let us move on to the next problem. See here, this is also one of the statement question given problem here. Statement, if you see here, a resistance R is connected. So just you draw the circuit first. A resistance R is connected in series with a parallel comprising of, so here, so a parallel comprising of, so how much resistors, like this. So once again the same circuit what we have seen in the first problem, that is 20, here it is a 48 ohms, here it is 48 ohms. The total power dissipated in the circuit is 1000 watts. That means the total power 1000 watts is the power consumed in the entire circuit, that is given it as 1000 watts. And the applied voltage, and voltage also it is given as 250 volts. The applied voltage it is given as 250 volts. Calculate the R and current through R. So here power, see, for power consumed, so power consumed in the entire circuit it is given as 1000 watts. 1000 watts. So power can be written as, what we can write, the power can be written as V square by R. R here, V square by R equivalent. In this R equivalent, what is the problem here? So R equivalent, if you write here, R equivalent is equals to R plus 20 into 40, because 20 is in parallel with 48 ohms. 20 in parallel with 48. 20 into 48. So you are getting R equivalent here. So, and you know the 1000, you know the voltage, everything you know except this R value. So just I am writing here R equivalent, we can write it as V square by power. So V square is how much? 250 into 250 divided by, what is the power here? 1000 watts. It is given in the problem. So just you substitute R equivalent also, that is 20 into 48 divided by 20 plus 48. So this is of problem. So you can cancel these two. So to 5 5s are 5 2s are, so totally it is 125 divided by 2 you are going to get. So here it is 125 divided by 2. So this is of work for you, I am giving for you. So you can get R equivalent value. So after getting R equivalent, so you have to find what is the current. So simply current flowing means, so current flowing through I is equals to, you can calculate V by R equivalent. So that is the current flowing. After getting R value, you will get the R equivalent. After getting the R equivalent, you can substitute what is the current flowing. That is entire total current you can calculate. The same total current is flowing here, because after coming to this point the current is divided. Up to this point the current is same. That's why you can consider the total current is same. What is the current flowing through R? So this is also given for 6 marks. Just I have given idea. Just I left for you to do the calculations, right? See next problem here. So in this problem it is given E. So E you have to given. So here it is given, I think so it is not given clearly. So here it is I1 is there. Okay, just I am writing for clarity purpose. Here it is I3 is there, and the question is asking what is I1, E, I3 and what is I. So these are the questions it is asking, and find the voltage across and it is given voltage across the 9 ohms resistor is how much it is given, 27 volts it is given. So from this data we have to do this problem. See, so here also you can use the current division rule once again. So first of all I will find, see, voltage across this 9 ohms resistor is given as how much it is given, it is already given 27 volts. It is given 27 volts. That means, so first I will find what is the current flowing through the 9 ohms resistor, that is given as I1. I1 is equals to 27 volts divided by 9, that is how much, that is it is 3 amperes. The current flowing through the 9 ohms resistor is 3 amperes. So because this 9 ohms as well as this 15 ohms, they both are connected in series, so the current flowing through that 15 ohms is also I1 only, that is also 3 amperes only. So if you apply the KCL at this node, so you apply the KCL at this node, apply the KCL at node A, I am writing here. If you apply the KCL at that node, so if you can see, so what is the current entering, it is the current entering here, it is I, that is equals to what are the currents leaving from that node, I1 plus I3 here. So I know the I1 value, I don't know what is I3 value, that I have to calculate. So for that purpose I am using the current division rule. So if you write the current division rule, I1 is equals to, you can write as total current into what is the opposite resistance for this 9 ohms and 15 ohms resistor, that is 8 divided by 8 plus 24. Total it is 24, because 15 and 9 they both are in series with each other. So I know the I1 current is 3 amperes, I 8 by 32, 8 by 32, that means 8 ones are 8 fours are. So I value will become 4 into 3, that is 12 amperes. The current, total current is 12 amperes. If you know the 12 amperes total current, you can find very easily I3 value. So I3 you can find it as total current minus I1, that is total current is 12 and I1 is 3 amperes, that is remaining 9 amperes of current is flowing, that is in I3. So now you know the I1 value, I3 value, and you know the I value also. Finally how to find what is E. So what is E here it is. So here just I am reducing the entire circuit, because this first I am writing what is R equivalent here. What is R equivalent here? So 15 plus 9, they both are in series, that is in parallel with 8 ohms resistor. So that means 24 into 8 divided by 24 plus 8. So 24 into 8, just I am writing like that only, divided by 32. So 8 ones are 8 fours are 6 ohms. So total equivalent resistance you will get it as 6 ohms. So 6 ohms I am connecting here with the source, and just I am redrawing entire circuit, that is 6 ohms here it is connected, and I know the total current 12 amperes. So he is asking what is the E here. So just you apply the loop here. So what you will get? So E, and here the drop can be plus 2 minus, so that is 12 into 6 minus 72, that is equals to 0. So what is E you can write? Finally E is equals to 72 volts. This is the answer for the problem. So I think so you understand this problem. Let us move on to the next problem. See the next problem here. So this is not given clearly. So once again you see this, just I will write once again. Here it is 20 volts it is there across this, and here the resistor is there, that 10 ohms resistor, and here it is 20, and this is calculate the supply voltage V in the circuit shown. So this is the problem it is given. So this is also a very simple problem, you can do very easily. So if you see here, so first of all I have to reduce this entire network into a single resistance. If you observe this 20 ohms as well as this 10 ohms, they both are in parallel. Why I am saying in parallel? Because of current coming to this point. Just I will highlight the current. See here, so when you supply the current, so at this point the current is divided here like this, two currents, and after coming to this point, that is this point, the current is once again divided like this. So that's why I am saying it as, so if the current is divided, these two are in parallel with each other. So we can say it as, so that is just I will write the answer. So first I will reduce, that is this entire, first I will reduce this one. So just I will make it this as one box. First I will reduce this box, then we will see. So first box, just I am writing it as R1. So R1 I am reducing it as, so that is 20 into 10 divided by 20 plus 10, that is 20 into 10 divided by 30, that is 20 by 3, 20 by 3, I think so 6.666 ohms you will get, that is R1. So that is R1, that is R1 is in series with this 10 ohms, that is R1 is in series with the 10 ohms. So once again we will write it as R2. So R2 you are including this is also, and this 10 ohms and this 10 ohms, totally how much resistors are there here, this 10 ohms and this 10 ohms, and you are getting 1. So totally how much? 3 resistors are in series, that is 10 ohm, another 10 ohm plus, that is 6.66, total it is how much? 26.66 ohms. Here you got. So after that, so once again the circuit will be reduced. So up to this point we have completed now. Up to this point entirely we are completed. So you got the one. So I will draw once again the equivalent circuit up to that point. If you see the equivalent circuit up to that point, the resistor is there. Here the resistor is there, and finally you have one more resistor is like this. So you are having a resistor is like this. So what is this value? This is a value of 26.66, and this is the value of 20 ohm, and this is the value of 20 ohms. So this is the entire given. So now you can see, so here he is asking what is a V here. He is asking what is the V here. So that means 20 in parallel with 26.66 ohms divided by 20 plus 26.66. So that is equivalent up to what point? Up to equivalent this point. So up to equivalent you are getting one equivalent this point. So after getting some, so let us take this as some R3 here. So R3 is one equivalent. After getting R3, so one more resistor is also there here, this 20 ohms. So finally you are going to get total R equivalent. Just I am writing it as R4. You can write R4 it as, so what you can write, that is 20 plus whatever R3 you are getting here. That is the work I am giving for you. You have to do the calculations. R4 is equals to 20 plus R3 you are going to get, and finally the circuit will be reduced, will be like this. And thus entire the mistake is given in the problem, just I want to tell, because the total current is not given, you cannot find. So the total current is not given here. So 20 plus R3 you are going to get here, and V. If he has given the some 2 amperes, for example, just I am imagining, it is not given in the question. So if you write, if it is given it as some 2 amperes of total current is flowing. So total voltage you can write as that 2 amperes into whatever R4 you are going to get, that is the total voltage. Unfortunately in the question itself the current is not given, that is the total current is flowing in the circuit is not given. So this is of 6 marks question, and it is the previous question also. And see this next question, this is also one of the previous question, it is asked in the VTU exams. So see here, so this is of what is the question? Find the resistance across SM of the network shown in figure. So this is the figure. In this figure is asking what is the total resistance. So okay, so if you see here, so if you rotate this, just I will rotate and show, see here. So this diagram, so once okay, so it is not possible to rotate. So if you see the diagram in this view, so if you see the diagram in this view, so if you see that, so see this 1000 ohms and this 1000 ohms, they both are in parallel. So that's why I am going to reduce first. So 1000 in parallel with 1000. So first I am writing 1000, that is in parallel with 1000 divided by, that is 2000 you are going to get. They both are adding. 3 here, 3 will get cancelled. I think so you are going to get 500. I think so 500, right? So it is 500. This 500 total after reduction. So you are getting one reduction circuit. It is resistance. It is 500 here, 500 ohms. So this 500 and this 500 they both are in series. So what you will get another equivalent, that is 500 plus 500. So that is how much you are going to get, 1000 ohms. So you got the 1000 ohms up to this point, up to that point. Okay. So after that, once again 1000 and 1000. Here you can observe this 1000 is also in parallel. So 1000 and 1000, once again you will get the 500 because you got it here the same. So once again you will get 500. So what you will get here? So up to this point, what you will get? Up to this point. So once again you will get the 1000. So just I am redrawing the circuit. So that is 500 is there. After that you are having the totally 1000, and here you are having one more 1000 is there like this. So the circuit is simplified like this. So what is the values here? That is 500 ohms here, and here it is a 1000 ohms, and here it is the 1000 ohms. So once again, if you reduce this entire reduction of this, you will get once again 500. So what is the total resistance? We can say it as total resistance between S and M terminals is 500 plus 500, that is 1000 ohms. That is the 1000 ohms. This is given for 3 marks question. The